Here we have A3. It says draw the complete diagram of the circuit that uses a potential divider, ammeter, voltmeter, and cell to measure the current voltage characteristics for component X. So we're interested in this component X, the current voltage components characteristics. So I need to make sure that I have got an ammeter in series with the component, and we need a voltmeter which is in parallel with the component, and then we would connect it up like that. Now this arrow over here, can slide. It can either go that way or that way, and in so doing it will adjust the amount of current that will actually flow into here or flow into here. Now let me just explain that a little bit further. Let's just say, for instance, you have the situation where your arrow is over here like that. Now just imagine your current, let's call it, your electrons are coming through here. Now they are going to divide at this point. They're either going to go in this direction or in this direction. Now because you're right over here, there is no resistance there, so no current is actually going to go through this part over here because this has got much more resistance. So you're going to get comparatively low current, or just about a zero current, going through your ammeter and through your component X. But as I change that, if I have this situation over here, you've got your ammeter like that. Let's say we are now over here like that. Now when the current comes through, say your electrons coming through, which are going in opposite direction from your conventional current, but let's just view it from that point of view. Now it can either go there or there. Now here at this point over here, both this current, let's call this I1 and I2, both I1 and I2 will have to go through that part of the resistor. But this part over here, I1 will have to go through. So that we'll call that R1. And if this is R2 here, if R1 is bigger than R2, then we're going to have comparatively I2 will be bigger than I1. So as we slide this across here, the resistance R1 will increase, and therefore your I2 will actually increase because more current will flow through this part, because comparatively speaking this resistance over here will become less in comparison to the resistance here that it has to go if it goes through that path. And so we are going to get a varying current and therefore also a varying potential difference across this component X. Okay, so going on to the next question here. It says the graph shows the current voltage characteristics for component X. Component X is now connected across the terminals of a cell of EMF 2 volts and negligible internal resistance. Use a graph to show that the resistance is 0.83 ohms. Okay, well, at 2 volts, if we go up here, we are there, and if we go across there, each one of these is worth 0.2, so that's going to be 2.4 amps. 2.4 amps. So our R is equal to V over I is equal to 2 divided by 2.4, and if we divide that out, we should get 0.83 ohm. And then it says a resistor of constant resistance 1 ohm is connected in series with the cell in B and with X. Use your graph to deduce the current in the circuit is 1.3 amps. So let's just draw in then this resistance, what our VI, because it's 1 ohm, we're going to get V is equal to 1 times I. V is equal to Ri, so this is 1. So basically your V and your I are going to be the same. So you're going to get along here, you're going to get your something like that through there, and obviously it would go in the other direction also, something like that. So this would be the IV characteristics for the 1 ohm resistor. Now we have here that the total voltage must be 2 volts. Now what have we got? We've got something like this. We've got a 2 volt cell, 2 volts, and it's going through a resistor, and it's going through our component X, like that, like this, and this is 1 ohm, and there's a certain current. Now this V, let's call it V1, and this V2, V1 plus V2 must equal 2 volts. So I'm going to have it that I'm getting 2 volts, but I'm going to have it that when I add this, when I go across here, now they gave me a bit of a clue. They said it's 1.3 amps. So let's go to 1.3. This is 1, this will be 1.3. If I go across there and I come down here, I see there that I'm about 0.7 volts. That is for if I'm going across there, I'm going for my that's my component X. So for my component X, I'm getting 0.7, so that's my 0.7. And if I go across to my 1 ohm resistor and go down here, you can see there I'm about 1.3 volts, and that's together giving me my 2 volts. So it does seem that your 1.3 amps is going to give you your potential difference that you require of 1.3 and 0.7 giving you your 2 volts.